Hello, here is the problem on hydrogen atom. The question is calculate the probability of finding the electron in the ground state of hydrogen atom within 1 Bohr radius. For this we need the information of wave function of electron in the hydrogen atom in its ground state, that is this one, and mass I squared we know it's a probability density, and if I want the total probability over some volume we just have to integrate. So here it's not simple integration, it's integration over some small spherical volume, and this is small infinitesimal volume element, and in which the integration over the radial coordinate extends from 0 to a as asked in the problem. We need the probability only up to 1 Bohr radius. So r coordinate should extend up to only a, and as usual this theta and phi coordinate will range from 0 to pi and 0 to 2 pi respectively, and carrying out the integration. So here this integration, this 4 pi results from the angular part integration, angular variable. So we know that is standard, and what remains is only the radial part of integration. So this is 4 pi by a cube and the radial variable integration. So here you can see since r squared involves, we have to apply integration by parts technique to integrate this integral two times. So keeping track of all the variables will be very difficult. So one can follow this trick easily. Here the trick is, here you have to put the v, that is this one, and this is this is u and this is v. Okay, so here this side you have to keep on differentiate, this side you keep on integrate, and you see r square differentiation is 2r, difference further differentiation gives 2, and here integration of this will be the same term into multiply by a, in the denominator minus 2 by a, that comes as minus a by 2. Further differentiation will give you same term plus one more minus a by 2, that becomes a squared by 4, and further integration give minus a cube by 8. And finally you have to, when you multiply these two term cross term, you have to multiply with alternative plus and minus sign. Here you can see this term has to be multiplied by plus and this has to be multiplied by minus, again this by plus, this by minus. Okay, carrying out this multiplication, applying the upper and lower limit gives this. Here the first term is the multiplication of r squared with this term, and second term minus 2r by this term, and third term is this 2 times this gives this one. Now applying the upper and lower limit gives me this term, and further simplification gives me this, and so finally I get 1 minus, actually here it is 0.6766, I forgot to put this decimal. So you, if you simplify, you will get this as the answer. So probability of finding the electron within 1 Bohr radius in the hydrogen ground state of hydrogen atom is 0.326, which is less than zero point 0.5. Hence you can easily understand that electron wants to stay outside of 1 Bohr radius maximum time. So probability for electron to be outside of 1 Bohr radius is higher than within 1 Bohr radius. That's all. Thank you.